Hello everyone, so for today I'm going to be presenting SL MTS3201 Algebra question 4. Okay, so as we look at the question just now, the relation F is defined as all pairs xy where y equals to x squared. Okay, so looking back at the question, we need to list 5 different ordered pairs that are in set F. As we know, the relation F is defined as all pairs xy in the real numbers, where the second value y is equal to the square of the first value x. To list 5 different ordered pairs in F, we need to choose 5 different values of x, and we need to compute y equals to x squared. So for example, we just need to pick a random set of real numbers like 0, 1, -1, 2 and -2. So we just use x equals to 0 and then we enter it in the relation where y equals to x squared, and we will keep on repeating the same by using different real number 1, -1, 2 and -2. Okay, so all 5 of these pairs follow the rule y equals to x squared. So we know that all these numbers belong to the relation where y equals to x squared. Then we just need to write down all the numbers that are related to y equals to x squared, which they follow the rules. Okay, so now moving on to part B. For set A, we want all the values of x such that the ordered pair x4 is in the relation. So we use the rule y equals to x squared, and we set x squared equals to 4 because, as we know, y equals to 4, and as x squared equals to 4, we square root the number and the x squared, so we will get x equals to positive -2. Therefore, we will get a equals to -2, 2. Moving on, we go to the set B. It's basically just the same as the earlier in set A. Set B is all the x values that make the pair x and 10 satisfy the relation. So we set just like set A, where x squared is equals to 10 because we know that y is equals to 10 right now. And when x squared is equals to 10, we just need to square root both sides, and we will get x equals to positive and negative square root of 10. So therefore, our b will be equals to negative square root of 10 and square root of 10. we are going to set C. Well, for set C, the first element in the pair is already given as 5. So right now we know that x is equals to 5. So we just need to substitute into the rule where y equals to x squared. We need to substitute the x with 5. So y equals to 5 squared, where then y will become 25. And as we already have our answer, y equals to 25. Therefore, C is equals to 25. And finally, we have our set D. Finally, for set D, the pair is negative 3y. As we know, x is equals to negative 3. This is almost the same as set C. So we just need to substitute x equals to negative 3 into the relation where y equals to x squared. So when we substitute x with negative 3, we will get y negative 3 in a bracket and square. And negative 3 square is equals to 9, and y will equals to 9. Therefore, we will get d equals to 9. And that's the end for question 4. To sum up, the whole question is based on the rule y equals to x squared. In part A, we used the rule to generate 5 examples of ordered pairs. In part B, we applied the same rule to find the unknown x values or y values for each given set.
Yeah, today I will do SL question for question 6. So yeah, here's the question. So take a look at this question for question A. Okay, the first step is we should list all the domain and the range. Okay, this is the first step. For domain, we have 1, 2, 3, and 4. And the range is 2, 3, 4, and 5. So take a look at this. As we can see, W is one-to-one function. So we can conclude that W is a function. So for the conclusion, we can write as this: no element of the domain repeats, thus W is a function. Itulah, thus W is a function. So the second question is B. Take a look at this question. Okay, so we can repeat the step like from the question A, that we should list all the domains and the range for W. For Y. Right. So the domain is 1, 2, and 4. For the range is 6, 5, 9, and 3. From the question, we can see that there is element that appear twice. That is 1. So we can conclude that y is not a function because input 1 repeats with 2 different output, that is 16 and 19. 16 and 19. So we can conclude that thus y is not a function. Y is not a function. So it's the last question, question C. We just repeat all the steps from the question A and from question B. So, we list down the domain and the range. So the domain for question C is 1, 2, 3, 4, 5, and 6. For the range is 1, 2, and 7. 7. So after we list down the domain and the range, and we can see that domain for C only appear once. So it shows that R is a function. For the conclusion, we can write that each element only appear once, just like that, and we can conclude thus R is a function. Okay, that's all. Thank you.